Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking the first lesson in calculus differentiation. What is the title? Differentiation of trigonometry function. Remember, dear student, the last year we find differentiation of sine, cosine, tan. In this example, we find differentiation of sec, cosec, cotan. Dear student, look at the introduction about differentiation of trigonometry function. Dear student, what is the meaning of trigonometry function? The last year we were studied sine, cosine, tan differentiation. Today we are taking differentiation of sec, cosec, cotan. Dear student, look at introduction about trigonometry function. Dear student, the rate of change of the function f at point A and f of A equals limit when h tends to 0 f of A plus h minus f of A over h. Remember? Dear student, what is the meaning of the rate of change of the function f at the point A, f of A? Look at the point A, f of A. What you mean? If we have A equal 3, then f of 3, this point 3 and f of 3. The rate of change equal limit when h tends to 0, f of A plus h minus f of A over h. This limit is condition is exist when f dash A equal limit when h tends to 0, f of A plus h minus f of A over h. Dear student, look at in the opposite figure, we have two coordinates ox, oy. The slope of the tangent is known for all the points. We have point on the curve except for x equals b and x equals c. Dear student, look at the tangent of the curve at the point A. Look at this point A belongs to the curve, but when x equal b, x equal c, the curve is known except for x equal b and x equal c. Then we deduce the function when x equal c is discontinuous. So it is not differentiable at c x equals c. Why? The function is discontinuous at x equals c. Therefore, is not differentiable at x equals c. This is number one. Number two, the function is differentiable at x equals a. Therefore, f dash a is exist. This condition of f dash exists. The function f is differentiability at x equals a. Number three, the function is not differentiable at x equal b. What you deduce? Excellent student. F dash b positive not equal f dash b negative. Remember, dear student, when the function is not differentiable at x equal b, we deduce that f dash b positive not equals f dash b negative. If is differentiable at x equals b, we deduce f dash b positive equals f dash b negative. But in this case, dear student, f is not differentiable at x equal b. Why? Because f dash b positive not equal f dash b negative. Number four, the function f is differentiable on open interval ab is derivative has been found at each point. The function f is defined on closed interval ab is differentiable if a and only if each of f dash a positive and f dash b negative are exist, and the function is differentiable on open interval AB. Dear student, f of x is differentiable at close the interval AB if f dash a positive and f dash b negative are existed in the function is differentiable on open interval AB. Dear student, remember that number 1, d over dx a f of x equals what? Equals a times f dash of x. Remember, a belongs to R. What is R? Real number. When you find differentiation of constant times function, the first we write the constant times differentiation of the function. Remember, this constant belongs to R. Dear student, when we find differentiation of positive sum of difference to function, as example, d over dx f of x positive or negative g of x equals differentiation of the first positive or negative differentiation of the second. Then d over dx f of x positive or negative g of x equals f dash x positive or negative g dash x. What do you mean f dash of x? Excellent student. Differentiation of f of x. What do you mean g dash x? Differentiation of the second gx. Then we deduce that when we find sum or difference all 3, 4, 5 function, we find positive or negative differentiation of each function. Look at, dear student, d over dx f of x times g of x, product of two functions. What is the rule? The first f of x times differentiation of the second plus second times differentiation of the first. Remember, dear student, we multiply f of x, g of x, and define differentiation of product of two functions. The rule is, yes, write the first function times differentiation of the second plus second function times differentiation of the first function. After that, we are translate to another rule. When we find differentiation of division of two functions, f of x over g of x. What do you mean f of x over g of x? Yes, fraction function. Fraction function f of x over g of x. Differentiation is, look at the denominator equals gx squared, and denominator start from g of x times differentiation of the numerator minus numerator f of x times differentiation of denominator. Remember, dear student, when you find differentiation of f of x over g of x is g over x, g of x squared in denominator, in numerator gx times differentiation of x, f dash x minus f of x times differentiation of gx or differentiation of denominator. Remember, dear student, gx not equal 0. Why? Because in a fraction, yes, denominator is 0 is undefined. Dear student, if y equal f of z, z equal gx, then y equal f g of x is differentiable with respect to x. Therefore, dy by dx equals dy over dz times what? X and student, dz over dx. When you find dy over dx, remember y function in z, z function in x. The first we find dy over dz. After that, we multiply by dz over dx. This is chain rule. d over dx f gx equals f dash gx times g dash x. Remember, dear student, f function gx f gx, differentiation of f times gx equals f dash gx times differentiation inside bracket of f g dash x. Dear student, look at if is differentiable function with respect to x, and n is a real number. Therefore, d over dx f of x for all n. What is the answer? Equals n multiply f of x for all n minus 1. Dear student, remember, if we have function for all power n, what is the differentiation? We find n times f of x multiply n minus 1 times differentiation of inside bracket f dash x. Remember, dear student, if we have example 2x plus 1 inside bracket power 3, differentiation is 3 bracket power 2, and we find differentiation inside bracket. This rule is very important. When you find function for all power n, what is the differentiation? N multiply this function power less than 1 and multiply differentiation inside bracket f dash x. Dear student, if y equal f of x, therefore d over dx y power n equals ny power n minus 1 dy over dx. Remember, dear student, y function f of x. What you deduce? Yes, d by dx. What you mean of d by dx? Differentiation respect to x equals d by dx y for all power n, write in y power n minus 1 times dy over dx. Derivative of cotangent function. Dear student, before we translate to this example, we know that from the last year, differentiation of sine equal cosine, differentiation of cosine equal negative sine, differentiation of tan equal 6 squared. Remember, dear student, if y equal sine x, then y dash equal cosine x. If y equal cosine x, y dash equal negative sine x. But if y equal tan x, what is the y dash? Excellent student, equals sec power 2x. Dear student, look at differentiation of cotangent x. Derivative cotangent function. What is the differentiation of cotangent x? Look at, dear student, when y equal cotangent x. What you mean of the cotangent? Remember, cotangent multiplicative of tan. What is the meaning of the tan? Sine over cosine. What you mean of cotangent? Cosine over sine. Then we can replace cotangent x equal cosine x over sine x. Remember, x belongs to cotangent x, x not equals in y. N belongs to z. Therefore, differentiation of cotangent equal negative cosec power 2x. Note that, dear student, remember, dear student, in this example, dy over dx equals d over dx multiply 1 over 10x. Remember, dear student, we have cotangent x equals what? 1 over 10x. 1 over 10x mean cosine x over sine x. We find sine square x multiply rules of division of cosine over sine. Answer is negative 1 over sine x for all power 2. What is the multiplicative inverse of sine x? Excellent student. Multiplicative inverse of sine cosec power 2x. Then differentiation of cotangent negative cosec power 2x. Derivative of sec function. What is the sec? Sec is multiplicative inverse of cosine. If y equals sec x, where x belongs to R. X not equals 2n plus 1 over 2 by. What is the differentiation? Remember, n belongs to Z. Differentiation of sec equal sec 10. Why? Because sec is, yes, 1 over what? Yes, 1 over cosine. Sec, differentiation of sec x equals sec x tan x. Derivative of cosec function, remember, dear student, if y equal cosec x and x belongs to R, x not equal n by n belongs to Z. dy over dx cosec x equal negative cosec cotan. Remember, very important rule. dy over dx cosec x equals negative cosec x cotan x. Example. Now you are translate, dear student, to important example. Find dy over dx for each of the following. Number A, y equals 3x power 5 plus 4 cotan x. Look at the solution. dy over dx, dear student, equals 3 times 5x power 4 plus 4 multiply negative cosec power 2x equals 15x power 4 minus 4 cosec power 2x. Number B, if y equal 3 sec x minus 5 tan x, what is the dy over dx? dy over dx equals what? 3. What is the differentiation of sec? Sec tan. Differentiation of sec x equals sec x tan x. Differentiation of tan sec squared. Then when we find dy over dx of 3 sec x minus 5 tan x, we find, or we write, the constant 3 multiply differentiation of sec equals sec x tan x. What is the differentiation of tan? Equals sec square x. Then answer is 3 multiply bracket contains sec x tan x negative 5 sec square x. We take sine sec x highest common factor. Answer is sec x multiply bracket contains 3 minus 5 sec x. Look at when we find differentiation of the function y equal x power 3 cosec x. What is the dy over dx? Remember, we have product of two functions. Dear student, in this example, if we have two functions multiply f of x, g of x, what is the rule? We find f of x times differentiation of gx plus g of x times differentiation of f of x. In this example, we find derivative first, derivative second, plus second, derivative first. Look at the solution. When we find dy by dx, remember, we find 3x power 2 times cosec x plus x power 3 times bracket contains negative cosec x cotan x. What you mean? 3 is constant. X power 2, x power 3, differentiation of x power 3 is 3x power 2 times cosec x plus x power 3 times differentiation of cosec. What is the differentiation, dear student, of cosec x? And student, negative cosec cotan. Then answer is by highest common factor x squared cosec x. Answer is x squared cosec x multiply bracket contains 3 minus x cotan x. If y equal 1 minus cotan x over 1 plus cotan x, what is the differentiation of y? Or find dy by dx. Remember, dear student, this example is division or algebraic fraction. What do you mean of algebraic fraction? Algebraic fraction mean when you find y dash, denominator power 2 and denominator multiply numerator minus numerator times differentiation of denominator. Look at the solution. dy by dx equals what? Look at denominator power 2 multiply, look at the numerator, 1 plus cosine x is this is denominator, multiply differentiation of numerator is cosec power 2x, negative denominator power 2 times 1 minus cosine x multiply negative cosec x power 2. Therefore, answer is dy over dx equals what? Equals cosec square x multiply bracket 1 plus cosine x plus 1 minus cosine x over 1 plus cosine x for all power 2. Remember, cosine x minus cosine x, then by simplify 1 plus 1 equals 2 multiply cosec power 2x. Answer is 2 cosec power 2x over bracket contains 1 plus cosine x for all power 2. Find dy over dx if y equal sec bracket contains 5x plus 2, putting z equal 5x plus 2. Remember, dear student, we have find y equal sec multiply bracket 5x plus 2. At the first, we put z equal 5x plus 2. After that, we find dz over dx. dz over dx equal what? X and student 5. Why? Because 5x is derivative, its derivative is 5. What is the derivative of the 2? 0. Y is constant. Remember, dear student, derivative of the constant 0, but derivative of 5x is 5. Then when we find y equal sec bracket contains 5x plus 2, we put z equal 5x plus 2. After that, we find dz over dx equals 5 only. After that, we deduce y equal sec z, replace dy by dz equals sec z tan z. Therefore, dy over dx equals dy over dz times dz over dx. Remember, sec z tan z times 5 equals 5 sec 5. Replace z equal 5x plus 2. Remember, we replace z equal 5x plus 2. Then sec z tan z times 5 equals what? Yes, 5 constant. We start from the 5. Sec z, sec 5x plus 2, tan 5x plus 2. These examples is very important example. Therefore, dear student, dy over dx equal 5 sec 5x plus 2 tan 5x plus 2. Now we are to translate to another example. Find dy by dx if y equal cosine what? 3x. Remember, dear student, we have z equals what? dy over dx equals negative cosec power 2 cosine 3x times differentiation of cosine 3x. Why? Because we have cosine 3x, negative cosec power 2 cosine 3x multiply differentiation of cosine 3x. What do you mean negative cosec power 2x? The first times cosine 3x multiply negative 3 sine 2x. Why? This is differentiation of cosine 3x. Remember, differentiation of cosine 3x equals 3 or negative 3 sine 3x. Why? Because differentiation of cosine is negative sine. Differentiation of cosine 3x negative 3 sine 3x. Then answer is 3 sine 3x cosec power 2 cosine 3x. Another example. Find dy over dx if y equal cosec power 2 multiply 1 plus 3x for all power 2. Solution. Dear student, dy over dx, look at, equals 2 multiply cosec 1 plus 3x power 2 times differentiation of inside bracket times negative cosec 1 plus 3x power 2 times cotan 1 plus 3x for all power 2 times 6x. dy over dx equals negative 12x cotan 1 plus 3x power 2 multiply cosec power 2 1 plus 3x power 2. Another example. If y equal 3 minus 2 cotan x for all power 3, what is the dy by dx? Remember, dear student, we have function for all power 3, y equal bracket contains 3 minus 2 cotan x for all power 3. What is the required, dear student? dy dx. Remember, we have bracket power 3. Look at the solution. Solution is dy by dx 3 multiply bracket power 2. After that multiply what? Yes, x and student. Derivative of the inside bracket. What is the inside bracket? Negative 2 cotan x. What is the differentiation of negative 2 cotan x? Negative 2 negative cosec power 2x multiply by 3. Answer is 6 cosec power 2x multiply bracket contains 3 minus what? 2 cotan x for all power 2. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.